So, good morning, good afternoon to all of you. I'm going to
Good
show
afternoon, sir.
afternoon. So now I'll go to show
Morning, sir.
afternoon, please, afternoon. Everyone. So 1 minute, I'm going to show the updated PDF for today lecture. And in last lecture, we have discussed about linear diaphantina equations in two variables or two unknown. So we'll continue our lecture in today class. So reply me if you can see this updated PDF, my
Yes,
PDF.
sir. Yes, sir.
Okay, thank you.
Yes, sir.
Thank you. So see, in last lecture, we have discussed about linear diaphantina equation in two unknown, and linear diaphantina equation has this form: ax plus by is equal to c, where a, b, c are integers and a and b are not both zero at a time. And we have to now in this we have to find the integer solution, means we have to find integer x and one's y that satisfy this linear diaphantina equation. So we started in last lecture, we started with this equation and we observed that this equation 3x plus 6y is equal to 18 has several solution, and I think we have got we have discussed about at least 6 solution of integer solution of this equation. And then in the next example we have observed that this linear diaphantina equation has no solution at all. And we also discuss what is the reason behind why this linear diaphantina equation has no solution. And then we discuss a result which confirm that when a linear diaphantina equation has a solution. And this is your important result. This statement say that any linear diaphantina equation which has form ax plus by equal to c sorry has a solution if and only if GCD of a and b must divide the integer c. Sorry. And then we discuss the proof of this mathematical statement, and if you have any doubt we can discuss again. Then we provide several examples based on the previous result and discuss which linear diaphantina equation has a solution like this one: 6x plus 51y equal to 22 has no solution, and also write the reason behind. But this equation 33x plus 14y equal to 115 has a solution, and also I mentioned the reason behind why this equation has a solution. In third example, this equation also has no solution. I have mentioned the reason behind. But in fourth example, we have mentioned this equation has a solution and also mentioned the reason behind. Then fifth example, we have see that this equation has a solution, and then I provide a list of problem, and many of you have give the right answer which equation has a solution and which equation don't have solution. So we have discussed till this point in the yesterday lecture. Now we'll continue and see, because from here this example, I'm talking about this example 1.0.2, and this example gives some clue about the if has linear differential equation can have several solutions, not only one solution, several solutions, like this one. 3x plus 6y is equal to 8 has at least 6 solutions. We have already discussed that. So this example gives the clues about that linear differential equation may have several solutions, and based on this observation we have a mathematical statement. I did not write the proof because proof is not important at this point. We have to look for the application of this mathematical statement. I quote as a theorem 1.0.11. This is a mathematical statement. At least we need mathematical proof, but I did not provide this one. If someone is interested to look for the proof of this statement, you can follow this book. Can you see this book? I'm going to the title page. Anyone, please reply.
Yes, sir.
Yes. So this is your fundamental book of element number theory. Its title name is elementary number theory. Please write down somewhere. You can download this soft copy from anywhere. This book is freely available on Google. So the topic is elementary. Title of this book is Elementary Number Theory, and the author of this book is David M. Burton. So author of this book is David M. Burton, and the title of this book is Elementary Number Theory. And if you see this page number, okay, I'll show you the page number where proof is available. 1 minute, please give some time. So proof of 1 minute. Yes, the proof of this, I am talking about this theorem, and proof of is available on the page number 33 of this mentioned book, Elementary Number 3, written by Burton M. Burton. So you can download this book. So come to this one, because at timing I just ignore the proof. See what statements say that if we get one solution like x naught, suppose that this is one solution, because the main problem is whether a linear differential equation has a solution or not. In one cases or two cases we have observed that linear differential equation may not have a solution. If why not, then any other solution of the linear differential equation has this form: x naught plus b by dt and y naught minus a by d times t. See, what is x naught? X naught is the first component of your solution, whatever you got one solution, and y naught is another component. What is b? So b is this component of this equation, a is this one, and what is your d? D is nothing but GCD of a and b. So if equation is given ax plus by is equal to c, that means a and b is given, then you can find the integer d, which is the GCD of ab. So that means a, b, d is known, and from somewhere if you got one solution x naught, y naught, then any other solution has this form: x naught plus b by d times t and y naught minus a by d times t, where t is any integer. an integer. Let's see, I try to explain this concept through this example. I just ignore the proof. Proof is a little bit lengthy, and because this class is the mixture of CS student and math student, so that's why I sometimes ignore the big proof, mathematical proof. So come to the explanation of this theorem. Just I consider this linear Diophantine equation: 3x plus 6y is equal to 18, and you can easily see that this linear Diophantine equation has a solution, because if you look for the GCD of AB, A is 3, B is equal to 6, and C is equal to 18. So if you look GCD of AB, then GCD of AB is, what is this one here in this case? Anyone please reply?
3, sir.
3, sir.
3.
3. Okay, so GCD of 363, and you also know that 3 divides 18, that means this linear Diophantine equation must has a solution, and you can guess that this pair 4 1, that means x is a solution of 3x plus 6y is equal to 18, because if you put 4 in place of x and 1 in place of y, then left hand side is equal to right hand side. You can easily see that 3x means 3 into 4, 12 plus 6 into 1, 6, 12 plus 6 into 18. That is the right side. That means this is the one solution for 1. In fact, you can guess many solutions of this one. We have already discussed in the previous lecture. Because for explanation of any concept, we need a simplest example. That's why I consider this one. So here you just call x naught as a 4 and y naught as a 1. Okay. Now see, we can also easily see that this pair minus 6 6 is another solution of this given linear Diophantine equation. Because just you put minus 6 in place of 6x and 6 in the place of y, we'll see that left hand side of this equation is equal to right hand side of this equation. And see, this equation, this solution minus 6 into 6 has this form. See what this statement say, the theorem of 1.0.11 say that if you know one solution, so any other solution of this equation has this form: x naught plus b by d. What is your b? B is the second component, d is the GCD, and some integer t, and y naught minus a by d t. So y naught is given already. A by d is the GCD t. So see that here minus 6 by 6 has this form. Minus 6 can be written as, here x naught is equal to 4, your b is equal to, here in this case 6, so 6 I put here, your d is in this case, what is d here in this is 3, because GCD is 3, so d is here I put. And see, after observing that here t will is nothing but minus 5. You have to choose t is equal to minus 5, because 4 plus 6 by 2 is equal to 2. You put t is equal to minus 5, then you see that this equation is satisfied. 4 6 by 3 is equal to 2. 2 into minus 5 means minus 10. 4 plus minus 10 is minus 6. This is correct. Come to this one, because another is 6. 6 is y naught is here in this case 1, and minus, see the solution form, y naught minus a by d times t. I don't know what is t, for some t integer. T is only integers. So here y naught is equal to 1 minus 3 by 3, because 3 is a is equal to 3, d is equal to 3, and again t is same. In both place, same t will work. Here t is same thing as the t this one. So c is minus 1. The 1, 3 by 3 minus 1, and this one to 6. So that is 1. So here t is nothing but minus 5 in this case. In this another part, we also observe that this is another solution 10 minus 2. This is another solution of this given equation, and 10 can be written as, see that 4 is nothing but x naught plus 6 is nothing but b by divided by d is nothing but 3. Here t we have to choose 3, otherwise this equation will not satisfy. So t is equal to 3 here, because both part t will be same. So minus t is equal to 1 minus 3 by 3 is equal to 3. So in right side see that 1 and 3 by 3 is equal to 1. So 1 minus 3 is equal to 2 minus 2. So here in this, for this solution t is equal to minus 3. For this solution t is equal to minus 5. Now, your turn. You give another solution of this equation. Anyone, any other solution.
0 to 20
0.
minus 7.
What? 2 2 2 2, okay. Okay, for 2 2, what will be t? Then your next you want to find t in that case. For that solution we we find t. यानी कौन सा t होने वाला है? Like see that for this solution I got the t is equal to minus 5. For this solution I got the t is equal to 3.
Set t
Minus 1.
minus 1.
T is equal to minus 1. I have doubt. T is equal to minus 1.
Yes, sir. T is equal to minus 1.
Yes, sir.
Yes.
T is equal to minus 1. Yes, minus. Yes, good. Yes, thank you. So T is equal to minus 1. Yes, minus 1 will work. Okay, thank you. Now, can you give another solution of this equation? 3x plus 6y is equal to 18.
60, sir.
Which one?
60.
60. And for 60, can you find your T?
6 0.
For 60, can you find your T?
T equals to 1, sir.
T is equal to 1. T is equal to 1. This is
T is equal
1.
to 1.
Yes, T is equal to 1. Good. Yes, T is equal to 1. T is equal to 1. Now, another way. Suppose that this is one solution, 4 and 1. If T is equal to 4, okay. So see that. So that this result say that any solution, if you have one solution, so any solution of this linear differential equation has only of this form, There is no form. Suppose that you got another solution, you can see that that solution can be written as in this form. Your whatever solution, first component will be right in this way, and second component will be right in this way. So this result has some importance. If we get one solution, so any other solution of the same equation has this form, where x naught is known, y naught is known, b, a, d is also known. Only you have to look further what is t in that case. Now, so challenging part is, what is your first challenging part is, what is the at least one solution for the given linear differential equation. If you get one solution, we can guess many solution of that equation. So your challenging part is to find at least one solution, and I tried to write some example Like see that this equation 5x plus 20t y is equal to 8. This equation 5x plus 22y is equal to 18. So first you tell me whether this equation has a solution or not.
Yes, sir. Solution है.
I have
What is the
solution.
reason behind? What is the reason behind?
Sir,
GCD
GCD
GCD 1
one.
है sir और divide
GCD
करता
1
है
sir.
18 को.
Because GCD is one good and that GCD1 is dividing 18. Okay, thank you. So that means this linear differential equation has a solution. But what is solution? Can you guess any solution of this equation? Anyone? Can you guess at least one solution?
Yes, sir. 8 and minus 1.
8 and
Minus 1.
8 and minus 1. Okay, good. So 5 into 8, 40 plus 20 minus, yes. Okay, thank you. So that is one solution. Good, thank you. Any other solution? So suppose that if I ask that write down at least three solutions of this given linear differential equation, so that will be a challenging part that need some method to find, because one solution you can guess if data is small. If data is small, you can guess at least one solution. But if I ask that give at least three solutions, that is a difficult task. So we need some method. We need some method. We need some method. So see that for that I'm getting some sort of you are writing something. I don't know what is your problem.
No, sir. I was texting the Sudarshan, sir. Mistakenly, I write in discrete mathematics. Sorry, sir.
Okay. So see here, just you guess one solution, it's okay, but we need a formal method to find the solution. And how? What is the trick behind? See, first you have to anyway you have to compute the GCD of 5 by 22 to know that this linear differential equation as a solution or not. So first you have to compute the GCD of 5 and 22 and use the formal technique to for computation, and that formal technique to compute GCD is nothing but Euclidean algorithm. So always use this method to compute your GCD. That will help further. That's why I'm saying that always when you're computing your GCD, please always use your this formal technique known as Euclidean algorithm. So see, using this Euclidean algorithm, just I computing the GCD of 5 and 22. So 22 can be written as, see that in first line, I write 22 by using the division algorithm. 22 can be written as 4 times 5 plus 2. And I think this is first line is correct. Then after first line, you pick up the from the first line you pick up the divisor and the remainder, and then you apply the division algorithm in the next line. In between the divisor and remainder from the first sentence, you use the division algorithm. So 5 can be written as again 2 times, because here divisor is remainder is 2, the 2 times 2 plus 1. Then from the second line, you pick up the divisor and remainder and use your division algorithm. So you can write 2 is nothing but 2 times 1 is equal to 0. We have already discussed in your class, physical class, that in that one, in this way, you can conclude that this one, just the remainder which we get just before the remainder 0, this quantity which is a remainder just before the remainder 0 is nothing but the GCD of 5 and 22. So in this way, we also get the GCD 1, and you know the 1 is divided 18. So this equation, given equation 5x plus 22y is equal to 18 has a solution. Now, this is not so important because we have many way to compute your GCD. This is one way we have many way to compute GCD. You can also guess. So see, after computing, because see, then you know that your GCD can be written as linear combination of 5 and 22 in this case. In this case, because just you computing GCD of 22 and 5 and you got the 1, and we know one method that GCD of any two integer a b can be written as linear combination of a and b. So here GCD is 1, so we'll try to write 1 as a linear combination of 22 and 5. This is our second step. So what you do, we have to reward this method known as Euclidean algorithm, and in that way we get the values of x and y. See that. So this is our next step. So in next step, I try to write 1 as a linear combination of 22 and 5. So see that. Just I computed. So 1 can be written as from the, just reward the process. So 1 can be just 5 minus 2 into 2. Then you can replace 2 by this big quantity, 22 minus 4 into 5, and just simplify. Then I got 1 is nothing but 9 times 5 plus minus 2 times 22. That means this one. Now, and see, now we can see that why I are doing this one, because see, what is your ultimate goals? You have to find your x, y such that 5x plus 22y is equal to 18. See, you have to, your main goal is to find integer x and y. Integer maybe negative, maybe positive. You have to find integer x and y such that 5x plus 22y is equal to 18. Till this point, you got 1 as linear combination of this one. Now we know that because 1 is GCD and 1 divides 18, so that means 18 can be written as, now 18 can be written 18 times 1, and 18 is nothing but 18 times 1, you can write easily. Then in place of 1, you put this quantity, because 1 is equal to this one, and this expression has 5 has one component and 22 has another component. Just you put these values. So just 9 times 5 plus whatever minus 2, and then simplify. After simplification, we got 18 is equal to 162 times 5 plus minus 36 times 22. That means 18 can be written as this linear combination. That means x is in this way, x is equal to 162 and your y is equal to nothing but minus 36. That means this is one solution of your given linear Diophantine equation. See the method. And I think I think what is the name? Who give the solution? One solution, 8 and minus 1. I think Sudarshan.
Yes,
Sudarshan
sir.
are there? So I think
Yes,
you
sir.
tell the solution. Yes, you tell the correct another solution. Okay. This is the one solution. I use this method to find one solution. Now, suppose that this is your x naught, whatever I got this one x naught, and y naught is equal to minus 30c. Can in that case you can tell the what is your t? What can be your t?
Sir, 7.
So how you get a 7? Can you
7.
explain?
7.
How you get 7? Can you explain? Because this x is equal to 8. 8 is equal to 162 plus 22 because the solution what do we get this form. So 8 minus 162 will get the what is the quantity 8 minus 162 कितना quantity आने वाला है 8 minus 162 1 minus 154 so t is 7 t is 7 या minus 7
Yes. Yes.
-7, sir.
Minus 7.
Minus
I
7.
think I think t should be minus 7 not 7 your t will be minus 7 so see that so that's why I write here t is not only 7 t is minus 7 so you can easily see that and see using this so whatever you get solution that solution has this form only because here x not equal to 162 just I write this one and here a is equal to 22 b is equal to 22 so gcd is 1 d is 1 t that means 162 plus 22t because 22 by 1 is equal to 22 and y is equal to y naught minus 36 plus your e is equal to 5 d is equal to 1 t so minus 36 minus 5t so if you want this one y is equal to minus 1 whatever Sudarshan mentioned one solution 8 minus 1 so y is equal to minus 1 so minus 1 is equal to minus 36 minus 5t so minus 1 plus 36 means 35 35 is equal to minus t minus 5t means t is equal to minus 7 so here we also get the same thing so in that solution can you tell in this way another solution Sudarshan please try Sally if
Yes,
you
sir.
are there please try to find another solution so you try to find at least 2 3 solution come to the another example I have written the solution first I ask that I'm talking about problem 1.1.2 and this see the question I asked like this one determine whether the following linear Diophantine equation in two unknown has a solution. So this is your linear Fontaine equation. And if your answer is yes, then you find at least one solution of this linear equation. So first task to check whether this linear Fontaine equation has a solution. Now you tell me whether this linear Fontaine equation has a solution.
Yes, sir.
Yes, sir.
So what can be
Yes,
GCD
sir.
of this number? First,
So GCD maybe 4.
Four.
maybe
Four.
what a maybe term of maybe.
4.
Mathematics student cannot use the term maybe. Please,
It is
if you are think you are a mathematics student, please don't use the term maybe. Can
Sir,
be.
4.
Yes. Okay. Thank you. Your answer can be either can be right or wrong, but not can be in confusing way. Only politician and the non-mathematical mathematics people use the term can be maybe. Politician or non-mathematics student use the term can be maybe. We people who is reading mathematics seriously should not use the term maybe can be. So see, maybe your guess is correct. So see, I use the former way to compute your GCD, and you know the former way, that means Euclidean method. Just see that we have to compute GCD of 172 and 20. So just you write 172 in this way, 172 as this one, 8 times 20 plus 12 in the next, I think
Sir, 2 minus 9.
Five.
Sir, one solution
very
is
useful,
2 minus 9.
5, 7.
very doubt. Have you any doubt?
Sir, 5, 7.
5 7 means
sir 0 15.
050 किसका सॉल्यूशन है ये?
Sir, another solution.
किसका सॉल्यूशन?
ये x और y मान रखेंगे.
किस प्रॉब्लम का सॉल्यूशन है?
सर वो लीनियर डायफंटाइन का बोल रहा है इक्वेशन का उसका सॉल्यूशन
मैं कौन सा प्रॉब्लम कौन सा है?
x
172x प्लस
1/2 x plus 20y
yes
इसका? अच्छा, ओके, क्या सॉल्यूशन है?
0 और 15.
0 and 15. Okay, 0 15 this one was correct answer. Yes, good, thank you. So see, we'll use this one because we try to use some method to compute, because this data is also easy. You can easily observe that 0 and 50 is a one solution, because put x0 to 0 and you know that 20 divided by this one, so easily you can put the 0 and some values of this one, will get the solution. So one solution is very easily found. So this, because data is easily, just by using this data you can easily observe at least one solution, you know. So but we want some technique to find, because in other question maybe your data is complex, so it is very difficult to guess your at least one solution. That's why I always use some technique. So in first step, you just compute using the Euclidean algorithm. So in this way, your GCD is 4. And C, after that, because your ultimate goal is to write 1000 as a linear combination of 172 and 20. Think about, your ultimate goal is to write 1000 as a linear combination of 172 and 20. And you all know that 1000 can be divided by 4. That means 1000 can be written as 4 times 250. So anyhow, if you can manage to write 4 as a linear combination of 172 and 20, then you multiply both sides by 250. Then what your goal you can achieve, because your ultimate goal is to write 1000 as a linear combination of these two quantities, 172 and 20. So what you do, just by using Euclidean algorithm reversal process, you first write 4 as a linear combination of 172 and 20, and you know that 1000 can be written as 4 times 250. So just we multiply 250 with both sides, then we'll get your goal. So same thing I doing here. So in first step, I write 4 as a linear combination of 172 and 20 by using reversible process of Euclidean algorithm. And then because you know that 1000 is nothing but 250 times 4, and just I replace 4 by this big quantity and then simplify. So finally we got this solution. In this way, your x is equal to 500 and y is equal to 4 minus times 4250. So this is another solution. One solution Puneet has mentioned, 0 and 50. This is another solution, and this is another solution. And using this one, you can get many solution and general form of any solution of this form I mentioned here. In any solution of this equation, because we have one solution, so we can, any solution we can write in this way. Because this data is smaller one, so you guess that. Now come to this question, because yes, this one. First you tell me whether this equation, question number 1, has a solution or not. If your answer is yes, find at least one solution. Because data is little bit complex, because 2173, 2491, first you tell me whether this equation has a solution. If your answer is yes, then you tell me at least one solution of this linear diaphantan equation.
Yes, sir, it has solution.
So what is GCD of this two number?
53.
Huh?
53. Yes.
53. GCD is 53.
Yes, sir.
Yes, sir.
Confirm.
Yes, sir.
53. Can you post your solution to method to find your GCD on the common WhatsApp group? Yeah, there are many CS students who cannot see easily the GCD of these two numbers. That's why I'm asking, please send whoever retain the formal way to write the GCD. To find the GCD of these two numbers, please post your solution on the common WhatsApp group so that many of you who did not know the method can see at least the solution, the way to find the solution.
सर हम सीएस वाले का भी ग्रुप बना दीजिए सर।
क्या?
हम सीएस वालों का भी ग्रुप बना दीजिए सर, उसमें हम लोग भी देख पाएंगे।
सीएस वाले तो किसी ने कहा था कि आप लोग उसमें मर्ज कर दिए, तो आप लोग पता नहीं ईगो इतना भरे पड़े हो, आप लोग मर्ज नहीं हो रहे हो। एक ग्रुप बना है डिस्क्रीट मैथमेटिक्स का, उसमें आप लोग इन्वॉल्व क्यों नहीं हो रहे हो?
सर उसमें सर हम लोग को उसका लिंक नहीं मिला है सर।
लिंक कोई नहीं भेजा है क्या?
नो सर।
सभी लोग ईगो से भरा हुआ है लगता है। मैथ वाला सी दैट इसमें मैं शेयर नहीं कर पाऊंगा, बिकॉज जो भी इसका ग्रुप को बनाया है, आई डोंट नो उसमें कुछ कंडीशन होता है। आई टेल यू द ट्रूथ बिहाइंड। 1 minute, जस्ट आई एम गोइंग टू चेक द ग्रुप and why I'm not able to share the link, because in this group I am not group admin. Because in this group I am not group admin, so there are many group admin. That people should share the link to the CSC student. There are, I'm observing 5-6 group admin is there, but no one shares. This very bad thing. Sudarshan, are you there? Sudarshan, Saurabh Kumar Paul.
यस सर। सर सीएस के सर कोई भी सर स्टूडेंट सर कांटेक्ट में ही नहीं है।
भाई एक नंबर नोट कर लो।
नंबर नोट करो उनको।
909।
इस पे ही भेज दो, इस पे जो इस पे हो रहा है इसी में लिखो ना, नंबर शेयर करो, यहाँ पे चैट बॉक्स में नंबर शेयर करो।
ओके ओके।
सीएस के जितने नंबर चैट बॉक्स में शेयर करो, जितने भी स्टूडेंट हैं। और सुदर्शन या सौरभ जो भी है, कुछ नंबर आप नोट करके आप लिंक शेयर करो, सबको ऐड करो।
ओके
क्योंकि इस ग्रुप में मैं ग्रुप एडमिन नहीं हूं, तो मेरे पास पावर नहीं है इसमें ग्रुप में किसी को जोड़ने के लिए।
सर आपको ग्रुप एडमिन बना दिए?
आप मान लो बना दे, दूसरी बात है, पहले तो नहीं थे हम ना। बहुत सारे, ठीक है। आप लोग क्या करो, जितने लोग ग्रुप में जितने भी छूटेंगे, आप लोग आपस में लिंक शेयर करके सब लोग जुड़ जाए। कल से मैं एक्सक्यूज नहीं सुनना चाहूंगा। ये जिम्मेदारी सुदर्शन है।
भाई एक को ग्रुप एडमिन बना देना, सीएस के एक को ग्रुप एडमिन बना देना।
हाँ, सीएस से किसी स्टूडेंट के ग्रुप एडमिन बना दो ताकि वो सबको जोड़ सके। और कल से ये एक्सक्यूज नहीं मैं सुनना चाहूंगा।
ओके सर, थैंक यू सर।
ये रिस्पॉन्सिबिलिटी आपकी है और आपकी रिस्पॉन्सिबिलिटी है। कल से मैं एक्सक्यूज नहीं सुनना चाहूंगा।
ओके सर।
-8
नहीं समझ पाया मैं आपका आंसर। किसी ने कुछ रिप्लाई किया, मुझे समझ नहीं आया, कुछ ने कहा है क्वेश्चन में।
Sir, x naught is 7 and y naught is -8.
Here in this case.
Yes, sir.
So how you
Yes,
get this
sir.
solution? Can you share your solution, please?
Sir, I am not in any group, sir.
So you are from the CS group, a CS student.
Yes, sir, I am from 60.
So you share your solution on the CS group, because there is only one group where I share the link. जहाँ मैंने लिंक शेयर किया तो वहीं पे पोस्ट करो, मैं यहाँ से वहाँ पे कॉपी करके यहाँ डाल देता हूँ।
सर उसमें मैं एडमिन नहीं हूँ तो मैं शेयर नहीं कर सकती हूँ।
तो ये भी लफड़ा है, जो एडमिन होता है वही शेयर करता है क्या?
यस सर।
पोस्ट तो कोई नहीं कर सकता है। पोस्ट तो कोई भी कर सकता है।
बट सर एडमिन ही उसमें शेयर कर सकते हैं, हम लोग नहीं कर सकते।
ऐसा है, मुझे नहीं आइडिया है। कोई, चलो कोई बात नहीं। So I'll share this PDF to all of you। और 4-5 क्वेश्चन मैंने लिस्ट किया है, अभी लोग सभी क्वेश्चन ट्राई करने की कोशिश करेगा। और कुछ डाउट भी होगा या सॉल्यूशन आप लिखते हो तो ये व्हाट्सएप ग्रुप पे आप शेयर करिएगा। Whoever get the solution, please share your solution on this common WhatsApp group only, so that all of you can see the solution, or if you get some error, they can comment. Anyone can comment also on any solution if you have any some point. So our time is now over.
सर
Okay, then thank you.
एक्सक्यूज मी।
Sudarshan, Arudhi,
यस
please.
सर, एक सीएस स्टूडेंट को मनीष गुप्ता को मैंने एडमिन बना दिया है, वो सबको ऐड कर देंगे सर
तो
ग्रुप
मनीष
में।
गुप्ता कहाँ है? मनीष गुप्ता, आप मनीष हो यहाँ पे? मनीष,
यस सर।
चैट बॉक्स।
तो मनीष आप ये कर पाओगे?
ओके सर, आई विल ऐड।
ओके, ठीक है, थैंक यू। तो ठीक है सुदर्शन, है तो मनीष जी, ये
ओके
जितने सीएस की स्टूडेंट है सबको इस ग्रुप में आप ऐड कर लो, ठीक है?
ओके
कल
सर।
से कोई इशू ना हो, ठीक है? थैंक यू। देन थैंक यू, थैंक्स टू ऑल ऑफ।
थैंक यू सर। थैंक यू सर।
थैंक यू सर।
Thank you, sir.